formed from lush plants that grew on the earth over 300 million years ago. After being buried underground and squeezed harder and harder, the plants became the rocky black substance we call coal. Hi, I'm Barb, and together we're going to explore the world of coal in Kentucky. This video series will help us all understand what coal is and what it means for Kentucky. In this first part, we'll learn what coal is and why it's found in Kentucky. We'll travel to coal mines all over the state and learn how mined land is put to new uses. So hold on to your hard hats. Here we go. Coal is important because it makes a lot of heat when we burn it. Because coal burns well, America needs it so our industries can do more. Coal was first used by Native Americans well before Europeans arrived, but Kentuckians have been using coal for over 200 years. On April 13, 1750, Dr. Thomas Walker found coal in Kentucky, and within 70 years, coal mines were opening up throughout the huge coal fields in East and West Kentucky. Early in the 1800s, blacksmiths used coal to make all sorts of things such as metal tools and wagon wheels. And soon, trains were chugging throughout the country, pulled by coal-fired steam locomotives. Coal is baked in hot furnaces to make coke, which is used to make steel from iron ore. In the early 1900s, coal was being used to make electricity that powered things like electric streetlights. However, oil was still used to make most of America's electricity for our homes, businesses, and schools. But in the 1970s, we couldn't buy oil from the Middle East, so oil and gas prices went way up. This made coal even more important for making electricity. As the need for coal increased, Kentucky became the #1 coal-producing state in the country. But you may be asking, how does coal really affect my life? We all use a lot of electricity, and we can make electricity by burning a fuel such as oil, natural gas, or coal. Coal has many advantages over these other sources of energy. Abundant! The United States produces 1/4 of the world's coal, second only to China, and many U.S. coal beds are close to the Earth's surface, which make them easy to mine. There are over 400 billion tons of coal we can mine with today's technology, and there are nearly 4 trillion tons in the ground that we may be able to mine with future technology. That's enough to last us a very long time. Useful. Coal is used as a fuel to make more than half of all the electricity used in the United States. It's also used to make steel, cement, paper, and other products. A good alternative. Greater use of coal means we don't have to rely so much on other countries for the energy we need every day. Jobs. Coal is a homegrown industry that many towns depend on for jobs. And as new technologies are invented, people who know how to use the tools will be needed. Computers, math, and science are more important than ever in the coal industry. So you see, by knowing more about coal, you can help make important energy decisions for yourself, your state, and your country.
In a very simple way, the coal is a rock that burns.
Okay, the main types of fossil fuels are oil, and natural gas, and coal. And all that means is that they are fuels that come from fossil living remains. So plants having once been alive become fossilized. Their organic matter is what we burn as a fuel, and coal is one of those types. I have some of those examples right here. These ferns lived in a swamp 310 to 320 million years ago. And they settled down in the mud, and their imprints were left in the mud as a fossil. These look kind of like flowers, but they're really leaves on a stem, and it was something that looked like this. Here's the stem, and then these are the leaves coming off the stem.
Here's how coal was formed. More than 300 million years ago, plants grew in swampy forests that covered many parts of the earth. In Kentucky, these swamps covered what is now the eastern and western parts of the state, as well as many surrounding states. The plants grew and absorbed the sun's energy. As the plants died and fell into the swamp, new ones grew in their place. And when these died, still others grew. Well, as the years went by, a thick layer of dead plants accumulated at the bottom of the swamp to form a spongy brownish material called peat.
And this is a piece of peat. It's very soft and crumbly. You can still see some of the plant remains in the peat.
As sea levels changed and rivers flooded, sediment covered the peat. As layer upon layer of sand, mud, and clay piled up, the peat was further compressed by pressure and heat, squeezing out most of the water. As if in an oven, layers of peat were cooked until after millions of years, they hardened to what we call coal.
Plant material has a lot of carbon in it. It's an organic material, just like anything. And when we heat that plant material, the carbon turns black. And the same thing if you heat wood in a fire, you take a piece of wood, burn it, it'll turn black.
There are 4 major types of coal that are classified by hardness. The harder the coal, the less moisture it contains, and the hotter it burns.
We have the next one here. It's a piece of subbituminous coal. And there's still some little brown and yellow flecks in there, but you can see it's starting to get shiny. And this is the coal we have in Kentucky. It's called bituminous coal. You can see it's very shiny, and there's many layers in it. And then the last stage for coal, when it's heated under intense pressure, would be anthracite coal. And you can see it's very shiny, and it's very hard. The hardness comes from the pressure, and that you're continually putting these things under more and more pressure as you bury them through time.
Today, coal is found in 38 different states. But we're here to learn why coal is found in Kentucky.
We know what the rocks look like at the surface, but we want to know now what they look like underground to help explain why the coal is where it is. So imagine we take a knife and we cut through Kentucky, and we look at how the rocks are layered beneath the surface. And what we can see is this gray area here, the Western Kentucky coal field. Places like Hopkins County, Webster County, Henderson County. The gray occurs in a bowl here. Gray rocks. That's the rock that has coal in it. And all of the rocks kind of dip in that area. It's what we call the Illinois Basin. We go towards the east into central Kentucky, Fayette County, Jefferson County, and we see that we don't have that gray rock anymore. It's gone. It's been eroded. And the older rocks, these purple rocks, are pushed up to the surface. We go back into eastern Kentucky, counties like Breathitt and Knott, Perry, Pike County, and we get the gray again. That's the coal-bearing rocks. And that's called the Eastern Kentucky Coal Field. It sits in another depression that we call the Appalachian Basin. So basically we have 2 bowls that filled up with coal-bearing rocks. And then we have an area in the center of the state, which we call an arch, where the rocks have been eroded.
In East Kentucky, coal is found in a 37-county area. In West Kentucky, coal is found in a 19-county region. Kentucky coal seams run from 2 feet to 8 feet thick, and the distance underground varies widely.
Bituminous coal basically means that's the rank of coal, the rank of the plant material, how hot it's been heated, how much time it's been underground, how much pressure it's gone under. The coal in Kentucky has been in the ground for 300 million years. It was buried by thousands of feet, if not miles of sediment, and that has been eroded. And all that pressure and time heated it to the point where it is now bituminous coal.
Kentucky still has a lot of coal in the ground, over 91 billion tons, and only 14% of Kentucky's coal has been mined over the last 170 years. I bet you're wondering how we get coal out of the ground. Well, it's not easy, and it takes a long time. In the earliest mines, coal could only be taken from seams close at the surface. Mining had to follow the coal bed underground, where it was mined by hand. Mules, horses, oxen, and even goats were used to haul coal out of these early mines. Eventually, machines made mining easier and faster, and electric trains replaced our animal friends. There are two basic ways to mine coal: underground and surface mining. Underground mining is used when the coal is deep below the surface or in hilly land like East Kentucky. In Kentucky, underground mines are either drift, slope, or shaft mines. Drift mining is used to reach coal that's located in a hillside. The entrance is usually where the coal is seen on a hillside and a horizontal tunnel is cut in through the coal. A second entrance is made to allow air to ventilate or flow through the mine. Miners get into the mine by riding a man trip. These allow many miners and their equipment to ride to where they need to work, which in some mines can be 6 miles from the entrance. This man trip has rubber tires. Slope mining is similar, but the entry is slanted and everything moves in and out of the mine through the slope shaft. Additional entrances are made to ventilate the mine with fresh air. A man trip is also used in a slope mine. This one travels on a rail. A shaft mine reaches the coal through 2 openings down into the coal bed. 2 elevator shafts provide vertical access to the coal bed. One shaft is used to transport workers and equipment, and the other is used to send coal to the surface. Most mines have an area nearby where the coal is cleaned and sorted. For many mines, this processing area is located just outside the mine entrance. But for others, the coal must be moved to the processing area by truck. Most underground mines use a room and pillar system. The miners take out the coal by cutting a series of rooms into the coal bed and leaving pillars or columns of coal to support the mine roof. As mining advances, a grid-like pattern forms in the coal bed. The grid can be 400 feet wide and more than half a mile long. In a single mine, several room and pillar areas may be going on at one time, all connecting to the access tunnel. When as much coal as possible is removed, the area is abandoned. The pillars can be left to prevent the land above the mine from collapsing. Generally, with a room and pillar mine, a little more than half of the coal is taken out because the pillars are left in place. In most mining, a big machine cuts the coal from the seam. This is called a continuous miner. The continuous miner has many safety features that make this type of mining safe and productive. First, the operator uses a controller so they can stay a safe distance from the cutter as the coal is broken away from the seam. Water spray helps keep the coal dust from flying all over, and like a vacuum cleaner in reverse, the continuous miner blows air away from the cutting area, so any other dust is blown away from the miners. The machine has sensors that monitor methane, which is an invisible gas that's mixed with coal. Currently, there is no way to separate the methane from the coal as the coal is cut from the seam, and if it builds up, the methane can explode. The continuous miner automatically warns the miners if the methane level gets too high. As the coal is broken loose, shuttle cars move in behind the continuous miner and the coal is pushed right into them. The miner then drives the shuttle car to the conveyor, where the coal is unloaded. Here the coal is sprayed with water to control the dust. A long conveyor belt then takes the coal all the way out of the mine to the processing area. As areas are mined, roof bolts are placed in the ceiling with a special machine. The person drills a deep hole in the roof. A long bolt is pushed into the hole with a tube of sticky resin slid around it. The resin attaches itself to the bolt and rock, securing the roof bolt in place. This keeps the roof from falling. Longwall mining is another underground mining method where robots and computers are used in coal mines. A longwall miner is a huge computerized machine that cuts into a long coal seam. This radio-controlled robotic cutter moves back and forth across a long section of the coal seam. In some mines, this wall can be 800 feet wide. The coal is cut by a huge whirling blade and travels out of the mine on a flexible conveyor. This shearer has a large drum-shaped cutting head that strips 20 to 36 inches from the coal face on each pass. It rides a special track on the conveyor. Longwall mining is done under movable hydraulic roof supports, or shields, that automatically move forward as the coal face is cut. The supports protect the miners and machines from roof falls. The roof in the mined-out area is allowed to fall in behind the longwall machine, forming an area of broken rock called gob. Shuttle cars aren't needed, so moving the coal out is easier and faster, and a lot more coal can be mined since no pillars are left in place. So you see, underground mining is very complex and has a lot of high-tech machines that make it possible. But safety and training are important parts of any coal mine. In an underground mine, the workers must have fresh air. This is why there are always at least 2 openings. Miners regularly check the air quality to be sure fresh air is flowing into the mine. Every 20 minutes, miners test the air for methane to be sure this gas isn't building up to dangerous levels. Coal dust can make it hard to breathe. To reduce the amount of coal dust, powdered limestone, called rock dust, is spread all over, and water is sprayed on the coal as it's cut from the face. Every miner wears a self-rescuer in case of an emergency. Others are located throughout the mine where everyone can find them. In all mining, safety is a primary concern. The roof must be supported properly, air ventilation systems must work correctly, and electricity must be available in all parts of an active mine in order to give good lighting and keep the miners safe and able to work. And all this is done right because of careful planning that's done before any mining begins. Surface mining is used when coal is found close to the surface. Over 40% of all Kentucky coal is mined in surface mines. In West Kentucky, one method of surface mining uses a drag line. These giants are the largest land-based machines in the world. Drag lines are very expensive and run on electricity. What they do is uncover earth and rock over the coal. This is called overburden. At a surface mine, the topsoil is set aside or goes into other mined areas. Next, the overburden is broken into manageable sizes, usually with explosives that blast the overburden free. The coal is then removed and loaded onto trucks and taken to a processing plant. A second surface method is called contour mining and is used in the steep hills of East Kentucky. Contour mining starts at the edge of a hill and continues into the mountain until the overburden becomes too thick. This temporarily produces a high wall until it's filled back in. Once the overburden becomes too great, the coal may be removed with an auger, which drills into the mountain. As the coal is cut free, it's pulled out of the mine along the auger itself. The coal is then loaded into trucks and taken to the processing plant. Many coal seams are close enough to the surface so that the entire mountaintop is removed. This mountaintop removal is sometimes used in the eastern Kentucky coal field. At both underground and surface mines, a processing plant and transportation area are nearby. At the processing plant, coal is crushed, sorted, and washed. Crushing and sorting separate the coal from any rock mixed in with the coal. This rock is then returned to the reclamation site. Cleaning removes most of the stuff that cannot be burned. After processing, the coal is shipped to the customer by truck, railroad, or river barge.
So our big job then is to work with the producer of the coal and with the ultimate user, usually a utility or a big industry that uses coal for their power, and coordinate with them the movement of the product to get it from the coal mine to the ultimate user on the schedule that the ultimate receiver needs it delivered there.
We have dispatch people. Their jobs are primarily to coordinate the shipments of coal into the terminal from the mine origin onto the rail car, from a truck, going into our facility, whether we take that coal directly to a barge or to a stockpile. They coordinate and interface with barge companies, railroads, producers, analytical labs, end users like utilities.
Today, mining coal takes time and money and people who know what they're doing. First, the coal must be found.
We have records down through the ground that show where the different layers of rocks are underneath the surface. And when we find a coal bed, we try to figure out which coal bed that is. And so we can tell you exactly underneath the ground at any spot what coal beds are there, what aren't there. Basically it becomes, again, a game of connecting the dots. You know where it is at one spot, you know where it is at another spot, and then you use geology and a little bit of science and a little bit of guesswork sometimes to figure out where it should be.
Geologists determine the quality of the coal and the rock around it.
Most people don't know it, but coal has different qualities. The majority of the utilities look for the parameters of moisture, which is how wet it is, and ash, which is how much ash content it has, what doesn't burn. BTUs, a lot of people can't quite understand a BTU, which is the heating value, so I oftentimes explain it to them as calories, which is the same thing. And sulfur content, and of course with the EPA concerns and environmental concerns, sulfur is a big important factor right now.
Second, because mining affects so many things, it can take 2 years or more of planning before the mining actually begins. Detailed plans for mining, for safety and ventilation, for protecting the environment, and for what to do with the land after mining must be approved before mining starts. One of the most important parts of coal mining is what to do with the land after the coal is taken out. This is called reclamation. Reclamation starts with planning well before mining can begin.
In the pre-planning, what we do is we go out and we actually do surveys. We take samples of the water before the mining begins, the wells, people's wells in the area, and also the streams. Also, we do some biological assessments. We actually go out and count the bugs, count the trees, identify them, and to make sure what's there and monitor them as we go along to make sure that the mining industry isn't damaging any of the plant life, invertebrates, fish, that type of thing that's in the stream.
Today, with more information, new technology, and improved science, we can protect the land. After successful reclamation, it can be hard to tell which land has been mined and which hasn't. In fact, the restored land may be more useful than before. At a surface mine, as the coal is removed, reclamation immediately follows, according to the plan set up before mining started.
There are different kinds of soils that you're going to produce from the rock that you're going to disturb. Maybe you have a lot of sand versus a lot of clay or a lot of mud. That can help you plan what type of plants you're going to seed, for instance, in a surface mine afterwards.
Water quality is constantly checked to protect water supplies and reduce pollution. The overburden is pushed back into the mine with giant bulldozers, then contoured for water drainage and to blend with the landscape. The topsoil is prepared for planting, and the reclaimed land is managed for many years.
We think we're a good citizen, just like farmers, and using the land and putting it back for future uses.
So, what happens after the coal is mined and the land is reclaimed? If the reclaimed land becomes a lake or reservoir, water can be stored, benefiting plant and animal life. Mined land can be turned into forests, pasture land, or lake country for hunting, fishing, and camping. Proper care can turn steep, hilly land into space for new uses.
But the problem we have here is certainly everything lies between mountains. And, if you look from one mountain to the other, you can almost throw a rock across most of this. They cut back into the rock to get the cold off. Now, when they do that, then there is a large flat area made because of that. In a situation like this, they allow us to leave it this way so that we can get the flat area. We felt like we really got a good deal in the end, and probably no one would have ever thought of putting it here if it hadn't already been partially fixed for us.
The people of Kentucky are able to use the level land for everything from airports to schools, all because of proper reclamation. Coal is an important part of America's future, and we all must know as much as we can about it in order to improve how we use our natural resources and have good jobs in the future. This video series showed what coal is and how it's mined in Kentucky. In the next part, we'll explore how we use coal to make electricity. If you want to learn more about Kentucky's power source, check out the companion interactive CD-ROM that you can use on your computer. Travel deep into a mine and find out how the coal got there and how we use it to make electricity, as well as new technologies that are making coal more useful and clean burning. Order your CD-ROM today by calling the number on your screen.